Hello, in this lesson, I'm going to review finding the mean and standard deviation of a probability distribution. This is chapter 6.1 of our textbook. Suppose an experiment is repeated n independent times, and the value of a random variable x is recorded. The average value of x over a large number of repetitions of the experiment is called the mean or expected value of x, and we use the notation mu of x bar. Alright, mu x bar is given by this formula, summation of x times p of x. And the variance is summation of x squared times p of x, a whole thing there, and then minus mu squared. And to find the standard deviation, you can just take the square root of the variance. Now to calculate the mean, you can use a calculator. And we can also use the calculator to find the standard deviation. Now that once I get my standard deviation, sigma of x, I can just square it, right, to get to the variance. Alright, let's do an example. A Wendy's manager performed a study to determine a probability distribution for the number of people waiting in line during lunch, and the results were as follow. Okay, before we move on with the find the mean and standard deviation, let's talk about some requirement for being a probability distribution. So we say a distribution is a probability distribution if it satisfies two conditions. We say each probability have to be a positive number greater than equal to 0, and we said but it must be less than equal to 1. Let me rewrite it. So it has to be greater than equal to 0 but less than equal to 1. And the summation, when I sum up all the probabilities in here, I should get 1, right? So those are two requirements to be a probability distribution. Right? Note that we have a distribution here. This is my x, this is my p of x. If I add them up here, my summation of p of x is going to give me 1, meaning that if I add 0.02 plus 0.15, add all the way up to the last one with 0.02, you will get 1. And now each probability here greater than is equal to 0, greater than 0, and also less than 1. So this is a probability distribution. Right? Now let's kind of interpret what this means here. So 0.02 meaning that the probability that having no one waiting in line is 0.02. And let's do one more. And for 4, this line here, that means the probability that having 4 people waiting in line during lunchtime is 0.17. And notice that the highest probability is given by 3, right? The probability of that having 3 people waiting in line during lunchtime is 0.3, and the second highest is given by 2 people waiting in line. All right, let's calculate the probability. Okay, so first, I'm going to go to stat, put enter. Now in L1, you're going to enter the value for x, or the random variable, and in L2, enter the value for p of x. Once it's done, go to stat again, use the arrow, highlight, calculate. Now 1 bar stats is highlighted, so put enter. Now in L1, which is a list, put L1. And the frequency list, put L2. Once you've done that, hit enter, enter, enter. And you get the value of x here, the average. Mu of x equals 2.7, where sigma of x is 1.25 approximately. So the question asked me round to 1 decimal place. So to round it, I would have mu of x is 2.7, where a sigma of x is approximately 1.2. Okay, note that I use the notation mu of x and sigma of x because this is for a population. It's a large group of the experiments repeated many times. So this is approximated by using the mu of x, and the standard deviation is sigma of x. And this means that, on average, there are about 2 to 3 people waiting in line during lunchtime, which is kind of showed it in our probability distribution here, where 2 and 3 were two of the highest probability here. Now let's look at another example. In the next example, I'm going to go over finding mean and using a table which is computed by hand. This is question number 7 of the homework 6.1. This is one of the questions that are requested by students. Well, suppose a life insurance company sells $170,000 one-year term life insurance policy to a 19 years old female for $260. The probability that the female survived the year is 0.999603. A. Compute and interpret the expected value of this policy to the insurance. B. If the company sells 1,000 policy, how much should they expect to make? Okay, so we're talking about the profit here. We will talk about how much money the company gonna make, how much profit they're gonna make. So before we do, let's define our random variable. Think about what X represent here. So we say let X represent the profit maybe make from selling the policy. So X represent the money gain or loss by the company, or you can think of it as a profit made. All right. So for each policy, the policy holder either survive the year or not survive the year. So if the policy holder survive the year, that means the company will make that $260. And that is my X, right? In that, let me use a different color. And the probability of that, P of X, again, let me use color, P of X is equal to 0.999603. Okay, well, the person either survive or not survive the year. If the person not survive the year, that's unfortunate, then the company gonna have to pay out. Well, does the company pay out $170,000? Now think about it. Before the person, when you pay for the insurance, you pay $260 already. So you already pay $260. So the company actually only pay out $170,000 minus $260. So actually, the company actually only lost $169,740, right? So therefore, this amount here should be $169,700.40. Now, X is defined as the money that the company made, but if the person not survive, the policyholder not surviving a year, meaning that actually the company losing money. So that's how much money actually lost. Okay, and the probability of that would be 1 minus 0.99603, and which is 0.000397. Note that the sum of probability, if I add it up, these two numbers here should add up to 1. And this is our probability distribution. Now let's find the expected value. Recall the expected value is mu of X. And we say mu of X is given by summation of X times P of X. And so that is equal to, we have two X here, one is 260. So we have $260 times the probability, which is 0.999603, plus negative 169,740 times the probability of that, which is 0.00397, and calculate that, we'll get $192.51. Right? That is how much money the company can expect it to make for selling one policy. Of course, this is the average value as well. So we can write the interpretation as the insurance company expects to make an average profit of $192.51 on every 19 years old female it insures for 1 year. Again, so this is an average profit per life insurance. So, all right, part B. Well, if it sells 1,000 policy, then how much we expect to make? Well, one policy, it makes $192.51 on average. 1,000 of them, meaning can just multiply it. So the company can expect to make, on average, $192,510 per 1,000 policies. Okay, so Again, that's very profitable, right? So times 1,000, I get 192,510. Right? So this is the hand computation of the mean. Well, thank you for watching the video. I'll see you next time.